Are we good to go? طيب. If you, oh, I mute myself. talk, of course. It's called Gemini Live, and this is similarly with Google. Sorry, this is with Google, with OpenAI, Bedrock, all other suppliers. They do the same thing as well. What they did is they built an app on the top of their LLM, right? You can do the same. So think about what are the other applications. You can also tap into their models. Audio, you have text to speech, you have different models. You have the Pro and the Flash. Just try to add a dialogue, for example. It'll do the same thing. You can type. It'll take it to text. You can do the other way around. So just wanted you to make sure that you're aware of this. There's so many libraries here where you can go and like ready apps for you. Just explore them, please. You have few minutes to just explore it.
What's your take on the Firebase Studio that they came out with?
The what?
Firebase Studio.
Firebase?
Yeah, Studio. It's like Replit.
Ah, yes.
Yeah. But like back end, front end, and everything.
Yeah, there's also Lovable. There's so many other apps as well.
How do you go to the apps?
So you go to build. You see build? Yeah, go to build and check. Just check. These are some ready prompts, ready collections of things that you can do, just in case you don't have an idea. You want to know what you need to do. I shared Data Studio, AI Studio with you the first class. I was expecting you guys to go and search, but no problem. I'm here to guide. But please, if I give you a link, I expect you to go beyond that.
Is this free?
This is all free, but there's limits. Meaning there will be a time where they'll tell you, now you need to pay. But again, even for payment, it's not much. Probably the videos. And I told you about my friend Hashim, right? Did I tell you about my friend Hashim? So my friend Hashim Al-Ghaili, if you go to he's well known on Facebook. If you go to Facebook, you search Hashim Al-Ghaili. He has about 34 million followers. He puts videos. Some of them are good, some of them are controversial. But anyway, he puts scientific videos, right? He graduated from Germany. We used to be together in Yemen. What he does is he posted a few months ago saying that when View 3 came out, this model, he said, it used to take me 3 to 4 months with a crew of 16, 17 people with their cameras, with their equipments, and a budget of 100, 120K to produce a video that will be viewed by at least 10 million plus, because that's the number of the viewers that they go. He said now, with View 3 and Sora and these apps, I just need 2 weeks and the script and myself and a $2,000 budget of API calls, and I get exactly the same production that I used to get back then. And he feeds these models for fine-tuning, which we're going to be doing today, his own data. So you see, he's a world class in what he does, and now with these tools, he's even becoming what? More and more, right? So just to give you an idea, what apps are out there. Okay.
Can I ask you a question?
Yes.
We're going through everything Google, but there's so many other things out there that sometimes you're confused which one to go and use, right? So would you recommend sticking with Google for now? Or?
Start with something. I use Google because it's free. The moment you go for Claude, for example, you have to pay $5. The moment you go to $5 or more, when you go to OpenAI, you have to pay. So I usually go to Google just to show you the breadth of the things that you can do. But of course, you can use other services. And at the end of the slides, I'll show you what are other services. Google. Why do I use Google usually? Because number one, they're full stack, all the way from the chip to the application. Number two, they have a lot of money. They can afford to have some of these for free. Okay, I want to zoom a little bit onto reasoning models. This slide was shared with you last time. The door is closed, mashallah. Today we're having an amazing background. So we talked about reasoning models, right? We said the difference between the normal models and reasoning models. An example of a reasoning model? Uh-huh. What else?
2.5 Pro.
Okay, yes. DeepSeek, R1 and others. Now, so there's two things that goes into these, thinking models. So when they are trained, remember we said we get the base model. So let's take DeepSeek as an example. So we have a base model, right? What does the base model do? Does it answer my questions? No. What does it do? It finishes the sentences. Yes, it's a foundational model. It finishes my sentence. I need to have an instruction model to an instruction data set to get it to understand how to finish the question with an answer, right? So when they train it, it's called train time compute. When they train it, the data set they train it with, they make it follow steps. Remember we talked about chain of thoughts? We said instead of saying answer this with that, you go with steps. So here, when they train it, that instruction model or the instruction set was actually step by step. And I highly recommend, because we don't have time to cover everything, I highly recommend you go to this link. But basically, with a regular model, you ask a question, you get an answer. So for example, I have 10 apples. I gave 2 apples away. I ate 1. How many do I have, right? A reasoning model, what would it do? It will start thinking. It will start saying, okay, you have 10. You gave away 2, you ate 1, then this is the answer, right? Whereas a regular model will just give you the answer directly. Two very important terms, train time compute and test time compute. So all the new models that you have right now are more into the test time compute, meaning, yes, the model is out there, but still, we can get more out of it by applying test time compute, which is the thinking model. We said there's so many ways to increase, the power of every model, even if it's a reasoning model. Chain of thought, or what we say test time compute, even though they were trained to think, but also now you give it like a small prompt, it'll be able to give you the answer. But also tool use. We spoke about tool use. We spoke about the reasoning architecture as well. All of this is to increase the model output. We said we already kind of like hit a limit. There was a time where we thought that the model is the most important thing, right? We trained bigger and bigger models, but even GPT-2, when it was trained, they discovered there's a team called the Chinchilla team at Google. They discovered that, hey, this model, yes, it's huge, it's in the billions of parameters, but the data it was used to train it was less than the optimal, right? So now we have a method called the Chinchilla method, which is, I'm going to go over it, but please visit this link. It goes way in depth into scaling laws. It's called scaling laws. So yes, you need to scale the model, you need to scale the data, and also you need to scale the compute, right? Now, with the Chinchilla scaling law, what they discovered that the trade-off between the model size, the amount of data, and the given compute with the budget. Now, they showed that for a fixed compute budget, right, training a smaller model for a longer, more data leads to a better performance than training what? A larger model. And that's what the Chinchilla team proved. So they established what they call it, the what? Many existing were under-trained, as I mentioned.
Can we go back 1 second?
Yes. Do you have a question?
More time, less data?
Huh?
More time and less data?
Yes.
Okay, thank you.
No, more data. So they discovered that GPT-2 was trained. It was under-trained, meaning they give it a big model, but the data was not enough, meaning they should have supplied with more data. Now, with whatever you train, whatever you even fine-tune, you need to consider the Chinchilla optimal training in your mind. You'll hear this word a lot as we go. So this is an example for time test compute. Now you had OpenAI O1. Why am I using O1? Because it was the first reasoning model that came out. So this one as you can see, this is the time, the train time compute. This is how it was trained. And this one with the test time compute, meaning it gets the ability for the model to think even after it was what? It was trained. And as you can see here, when you compare it to the human, and this is, for example, in one area, in a competition code, or in a PhD level science, or even in a competition math, you find out that this is the human level. Just because it's O1 and it's a reasoning model compared to, let's say, GPT-4, right? This was trained. All the training was there, but when it was trained, there was no train time compute, meaning it was not trained to think. Now, how does this happen? It's a whole another story. But you need to also understand the trade-off. Yes, it reasons better. It has a lot of benefits that we get out of it, but it costs more in terms of compute, in terms of speed, right? If your application needs a lot of speed, then this model might not be the best. So you might need to start thinking about fine-tuning, right? So this is something you need to consider when you pick up the model. And similarly, with the evaluation, we talked about evaluation last time. So the model benchmarks, the PhD level science questions. So they had a PhD science questions. They were just trying it for chemistry. These are, again, GPT-2 and O1, right? And as you can see, it always exceeds. So there are certain areas which you can see here. When you have data analysis, right? When you have mathematical problem solving, experimental design, scientific coding, not just regular coding, scientific coding, literature synthesis, algorithm development, then these thinking models are the things that you need. Here are two different models, 4.0 and O1, all from OpenAI. And as you can see how O1 was able to come up with abstractions. It classified, so it understood that all of these are under circle. Whereas the model, the O1 model, or 4.0 model, was actually classifying them as bird. And so on. It got some stuff right, but not everything was right. So whenever you have a task that needs abstraction, reasoning models become the thing. This is the model I was telling you about that came yesterday, yesterday actually. It's called Kimi K2. It's a thinking model. When you compare it to the closed ones, like GPT-5 and Claude, Sonnet 4.5, it actually exceeds in certain areas. So think of the task. So browse cam, real world latest information collection. That's the name of a data set, a benchmark. The software engineering bench. You see? Yes, might not be, but this is an open source model. This is a model that you can go and download. So this gives us the case. This gives us the case that closed models, when they're in a specific domain, they actually outperform sometimes generic models. Any question here? Yes.
Thinking is the same as reasoning, right?
MashaAllah, the sound is so loud. You just told them? That's fine.
Thinking is the same as reasoning? Is thinking the same as reasoning? Same thing? Reasoning?
Yeah, reasoning and thinking, these are, we're using them exchangeably.
The regular models you showed in the first example, the 10 levels.
Yes.
You say it just answers. Does that mean it's like it's like someone who memorized the answer?
Yes. So it just predicts the next token. It does not generate tokens before it tells you the final answer. So that generation is the thinking model.
I'm sorry, Ibrahim.
Yes.
Repeat the last statement, please.
So he was asking the difference between the thinking and non-thinking. He was not here last week, but basically I was telling him, before it spits the answer, it generates enough tokens to think about the problem before it spits the answer. Internally.
Okay.
Some models, like for example, DeepSeek, it'll show you the thinking steps. Whereas OpenAI, they will not show you because that's their proprietary. Again, this is how the model was thinking. This is how the model was trained eventually, originally. The reason they don't want to show it because some people can use their APIs to get this thinking and use it for their training. Actually, they told in a blog that DeepSeek was actually doing this and taking. That's what they said. But of course, you can't just say you can't prove it. Okay, so we're gonna go one level deeper into the model. So I want you guys to go and go to your notes and click on the first exercise.
Quick question, please.
Yes.
So even if we prompted the model that we need to see the steps of reasoning, it will not show?
It was clearly instructed not to do so. But some other models, they will show you the thinking process. Everybody is in here? Raise your hand if you're not. So you click on the first exercise.
Do you have a QR code for this? I'm sorry, I joined right.
I do not have a QR code, but it's easy. It's bit.ly.
Okay.
Let me, I'll go back.
Sorry about that.
No worries.
Yeah, you get that.
bit.ly/Medina-labs. Please make sure it's capital.
Cap M, cap L.
Yeah, go ahead.
Dash.
And then go to the collab on exercise 1. And you should see something like this. So here, we will go a little bit deeper into the tokenizer and the embedder. We spoke about them previously. We said the tokenizer, what does it do? It's a model that takes, the original text and chop it into tokens, which is the unit that the model used to do all that training. And then what happens to these, let's say 75% of the word? What happens to them? They get embedded. They go into a number format so that, the model can do its math through the... So go and install Transformer. And if you work with LLMs, you will be using Transformers a lot. Transformers is a library by Hugging Face, which we will also explore by the end of today. Are you guys running it? Anybody stuck? Please raise your hand so I can check. You're stuck? Yeah, click on Open With.
I don't think signed up for Google Collaborator.
It's okay. Can you add it to your... Just add it to your drive and then open it from the drive. Yes.
I'm good.
You're good? Everybody's good? Take your time. Please take your time. Like, I want you to go see how it's what is in this. What I did in this one is I put certain colors. You can change them as well, just to see how these words are chopped. Go and open the variable. Try to see what's inside it. So as you can see here, we're invoking the transformers, and there's a library from Hugging Face, and there's something called auto tokenizer. This is one way to do it. There's so many other ways. You can go to the documentation. And I put the hello world, but please go ahead and put whatever you think. Can put a longer text and see. And then here, what I'm doing, as you can see, is I'm just loading that tokenizer, and I'm using a model called BERT base case, which is from Hugging Face as well. So it's a pre-trained model. And as you can see, the tokenizer JSON was loaded, the configuration of the JSON was loaded, the vocabulary text was loaded, and the tokenizer itself was there as well. Now, apply the tokenizer to the sentence. The tokenizer splits the sentence into tokens and returns the IDs for each token. Let's check the IDs, you see? These are the IDs of each token.
The number of IDs shows how many tokens it's created.
Exactly. And then you can see here, you have CLS, which is like a way for the BERT model to say this is a classification task. And then the last these are, you think of them as reserved token, just to say the beginning and the end. So class is classification, sep is separation, right? And again, as we mentioned, every tokenizer, where can I find tokenizers? Where can I find embedders? Hugging Face. And if you're, if you're OpenAI or others, Allah knows which server they are in. Now let's visualize them.
Visualize it. So Ibrahim,
Yes.
for example, I was looking at the Quran embeddings this morning.
Okay.
So let's say Bismillah ar-Rahman ar-Rahim, and you get all these the
Vectors.
Yes.
Uh-huh.
Now, how do these tokens get converted to the vector itself?
So you use, like, it depends on how many words did you use. If you just use the Quran,
Like a verse, right?
yeah.
Yeah.
No, if you just use the whole Quran as your vocabulary size,
Yeah.
then that vector will be of that space, right? The vectors is basically how are they close to each other in terms of distance. So basically the embedder calculates these distances.
So in this example, hello world could be the whole Quran.
No, in this example it will be the whole English language vocabulary. In this case it was about 35,000 words.
So it's your input that determines the space.
Exactly.
Yeah.
So you can have just the Quran, but then it's not going to be, it's just going to be specific to this world. If you try to ask a question or a word outside, for example, I have a word that is not in Quran, and I try to ask, it will never recognize it because it's out of this space.
Okay.
So it's an art by itself. You have like researchers that just, focus on this, yes.
How does it handle like languages like Arabic, for example, that have like each thing has a different conjugation that's like possible, like
So it takes it back to its roots. There's a lot of natural language processing that happens before that, but it takes it back to its roots. So the moment you do the tokenization process, it's actually taking the word to its token, which means, for example, playing, right? It'll take play, and then ing is going to be like hashes. You'll see it now. It'll be like hashes, and then this usually comes as a conjugation for verbs. Now we didn't do anything. We just gave it enough text and say, hey, this is how we speak the language, and it figured out, all of these language nuances.
so like you have to put a dictionary in for it to you have to put dictionary and
Exactly.
text, you have to put
Yes.
dictionary and text.
Yeah.
So okay.
Yeah. No. Not dictionary as a dictionary, but you put like enough text so that it starts thinking. So the more text you put, the more representative your embedder is. And there will be a time where it doesn't matter what language, because, it'll figure out that, these words come closer to these words, and these words, since they're closer, and now we are in the embedder space, so the word king and melik and whatever it's in Urdu, all are clustering in the same space. Yes. Yes, go ahead.
We're pulling 24 lines from a library or Hugging Face, which is great. But one of the lines, 20,
Mm-hmm.
it starts with blue, then it has orange, and then it has nested brackets. The curly braces are purple, and then blue, and then
Yeah, so it's just formatting, as you can see in the beginning, the F.
what are those for?
So the F here is just to format. So what I'm trying to do here, I'm trying to assign colors to each embedding, and I'm iterating, I'm looping, as you can see in this for loop. It's more like, this is Python. This is like pure Python programming language.
It's also algebra, nesting functions, or composing functions, or whatever you want to call it in the textbook.
Yeah, function.
I'm just curious, what does colors have to do with len? What does len have to do with IDX or set?
So colors is the name of my variable here,
Okay.
right? IDX is basically where the index of each one of these. So it iterates. It goes over every color and assign, a color to every index, which is, let's say, for example, in this example, For example, if I'm in the hello world, it'll take each ID and find the text. It'll become easier when you go to and you look at the visualizer. Look at this.
Yes, I remember seeing this on first week.
Yes. So this is exactly what happened. But you see, okay, now let's try different base models. So this was with BERT. Let's try here the other one, GPT-4. I have the token, so I'm able to see it. And then, of course, you can try other ones. So just more examples for you to see how tokenization in every model is different from others. Any questions so far?
Rahim, like, how these models decide like what's the most optimal way to make these tokens? Like, or this is something.
No, it's an algorithm.
What's the question, Ibrahim?
He is asking what is the best, how does each of these models decide what is the best way to tokenize something? Again, that's what happens. You have to design the entire training process. Again, garbage in, garbage out. Sometimes the tokenizer, they try multiple ones, and they try it on sample data, and if it yield the best prediction, then this becomes their best model, their best tokenizer. Now, sometimes they will come up with a whole new way of doing things. Most of this is open, meaning yes, there's a lot of active research, but not as sophisticated, for example, as how they stack, these transformers, right? Are you guys enjoying the background? Okay, so let's talk a little bit about local LLMs. So we've tried a lot of LLMs last week, but these were on the cloud, right? GPT-4 and others, and of course Gemini. But we want to run some of them on our computers. Yes, the more the model becomes smaller, the less knowledge it will have. But then if I can fine-tune it and make it work for my task, that specific task that I needed, then I'm a winner, right? Plus, every time it becomes smaller, it means less hardware. It means more performance, faster, right? It doesn't take time to do things. Okay, so what are the models that I can use? We can use Llama, Quinn, DeepSeek, Phi, Gemma from Google, Mistral, and Grenade from IBM. Now, these ones are proprietary. We cannot. GPT from Google, from OpenAI, they released a model called GPT OSS. Have anybody played with it? This is what my company is using now. It became our default way after LLMs. After Llama, we had Llama for a very long time, but now we're actually going to GPT OSS, open source model. 70 billion parameter, you download it, it's incredible. It takes about 8 H200 GPUs, and it's working perfectly. You can fine tune it, you can do so much with it. But what we're gonna do today, we'll take the Phi from Microsoft. It's a very small model. Actually, it runs on your phone. So a lot of the inference that happens on your phone, the intelligence on your phone, whether it's pictures, processing, or generation, or even Siri, which is not intelligent as of now. I don't know if you guys heard the news, but they're trying to sign now with Gemini, with Google. Yes. Finally, they gave up. Yes.
There has to be more on Hugging Face, right? Not just.
Yes, we will go in details. Llama, you have about 14,000 variations of Llama. So yes. Again, how do I enhance the performance? We did a lot of prompting, right? Remember last class, it was just prompting. We talked about chain of thought. The more prompt you give, I'll just give you from my experience. I write a prompt. It's usually 2 pages to get a task right. And I change this prompt to get to the right format about 30 to 40 times. So that's the scale. So if you're gonna use prompting, you should get used to this. I'm talking about like an enterprise, setting. But you could do it for smaller tasks, and you don't need much. But if you write 3 lines and you're not happy with the prompting, and you say, hey, I'm ready to go and fine tune, or I'm ready to go and bring a RAG system, then that's not the case. If it doesn't give you, if the prompt is not giving you, of course it's the best because you don't have to do anything. You're working with the LLM, you're leveraging the LLM knowledge, and you're codifying your experience in terms of prompt. If it's not working, then of course, if the knowledge is changing, as we mentioned, we use RAG. But this is what we're gonna talk about today, which is PEFT, right? PEFT is a way to do fine tuning. It's the most complex. It requires a lot of information. That's why we went into tokenizers and embedded today, because you'll be fine tuning, so you understand what you're dealing with. Required high quality training data set. If you don't have the data set, please don't even think about fine tuning. And it's very hard to get it. It's not easy. The last thing is you need a GPU. So if you don't have a GPU on your laptop, you won't be able to what? To fine tune. So we will be using Colabs because they give us also free GPU. Now, as you go from left to right, the cost increase, the complexity increase, but the what? The quality also what? Increase as well. Okay, what does it take? Okay, let's say I fine-tuned it. Now, what do I do with it? I need to serve it. I need to serve that model. That model, again, we're not talking about closed source, because closed source, this is done for you. It's a managed API. But if you were to fine-tune and now you have it, you need to serve it. You have multiple applications that use, let's say, this one model. So you need a server. The server has an engine. The hardware will be here, but then you need to track, the throughput, the latency, just to tell you how complex to serve your own model. By the way, even I work for a company, only for these customers that are on-prem, we deploy, the models for them. Otherwise, I just put it on Vertex AI on Google, or Bedrock on AWS, or other models, other managed service, because you need to manage all of this. And sometimes, if there's, it's just like an API key at the end of the day, but with a lot of complexities. And then you need to keep versions of it, because if a new one comes, you need to update. Just to tell you, what we were going to do is very important, but it's also complex. Okay, I want to serve it. Yes, go ahead.
What are the companies preferring now, especially with security being one of the biggest concerns? Are they preferring?
Okay, serving companies, there's one called Together AI, but just make sure they are SOC 2 compliant, SOC 2 Type 2 compliant. If you're working for a company and you want to serve the model through them, so I know Together, I worked with them. They serve also some of our models. There's also another company called Grok, right? You can also find some models there as well. They manage the hardware and the software. This company only managed the what? The software. Like, they built a software that is very optimal to do inference. They also provide hardware as well. Any other questions? There's so many others out there. Lambda. If you just type LLM serving.
They take the security risk in a way for enterprises.
Well, you have a customer. Your customer knows you. But yes, in a terms of incident, you could say, I relied on this guy, and this guy was not the person. Of course, you have all these companies, but then you have Together AI. Hugging Face, by the way, also serve. Hugging Face got into the serving. And funny enough, a few months ago, Facebook got into the serving business. But they only serve what? Their own models.
Which makes me ask, when it was in the news that Amazon AWS went down, I couldn't take attendance for my students that day. I couldn't send them to their classwork.
Believe me, a lot of people couldn't do anything at that time. A lot of servers were down because, again, it's a hyperscaler, meaning it's one of the biggest three. Actually, it's the biggest cloud. AWS is the biggest cloud. So governments, companies rely on them. So if they're down, everybody's down. Which gives us a question. We need a way.
Should I be happy that Facebook is going into the
Should you be happy? Yeah, in terms of model serving, yes.
So if I want a really tiny model,
Mhm.
have an application on top of it, I don't want the world to access it. Will I still have a lot of overhead? Because I think the world is moving towards that direction.
Yes.
Smaller model, which does not have a lot of overhead and limit things.
I'll show you. There's an example today where you can host them on your machine or on your servers. I'll show you that. But okay, so we have the hardware, the GPUs, and I have the model. How do I serve the model, which is the binaries, the file that we showed in the beginning, on this file, on this GPU? There's a software called LLM. I put the link here. It's an open source. 99% of the companies are using it. Well, let me be conservative. 80% of the companies are using it, including. So when I go to Google and I say, Google, can you give me GPUs? Of course, you're lucky if they do. They give me, let's say, 8 H200 GPUs, and they say, what software do you want on them? Do you want them to be VLLM or others, right? They also have their own Vertex, but usually that's what they serve. And then there's also TGI. There's also Tensor, TR from TensorFlow, if you're familiar. There's also PyTorch. There's so many other ones, but VLLM is the one that's usually used. Let's talk about fine-tuning. When do I need fine-tuning? So if you have data to fine-tune, what is going to change from the model when I fine-tune? Let's say I have a model that does so many things. Now I fine-tune it. What's going to change? Yeah. Like from a physical point of view, yes, there are parameters that are going to change, right? Instead of having a parameter that is 3.7113111, it's gonna, the numbers are going to change. But then from a behavior point of view, what's going to change?
The cluster of embeddings would change, like will bring it.
Okay. No.
Less hallucination, I hope.
Yes, of course, less hallucination. But what else? Better responsive for that specific task. Meaning the model is going to start zooming into what? Into specific knowledge. So if you fine tune a model, it's not going to be generic enough for multiple applications. So you need to be careful, right? Now,
Is that also true for these customer-facing like ChatGPT, Gemini?
yes. But they also allow you to fine tune, which we're going to be doing in a minute. Meaning you can take a version of GPT-4 and fine tune it for your specific need. You can do that.
And that's where they set the guardrails.
No, it will be,
Fine-tuning.
that model will be for you. You're only the one in the world that is going to be using that model.
But that's also true when I get an account and open like ChatGPT or Gemini. These models are also fine-tuned.
Yeah. They're fine-tuned. They're fine-tuned for. By the way, now with ChatGPT, when you use ChatGPT, by the way, there's a router. When whatever you submit, it goes to the router. The router decides a model. It decides what is the best model that needs to answer this. If it's something easy, then it gives it to an older model, which means it doesn't have to go and do a lot of execution. So this is the concept of agents, which I try to avoid in the whole lecture because it's a whole another game by itself. But you have multiple agents that are powered by multiple models that does this orchestration for you.
That's actually in ChatGPT 5, right? When they introduced 5,
then all of this became Wi-Fi because it's expensive. It's a huge model. It's a model that does so many things. So they empower it with a lot of agents on the top that does multiple things for you. Okay, so why do we fine tune? Number one, if I want a higher quality result than the prompting, if I want to utilize faster, cheaper models, ability to train on more examples than can fit in a prompt, right? You could have 2 pages, or you could have like.
FCWS policy.
No, it's like a million row. A million row might not fit in a context, for example, in a prompt, right? So you do that. Token saving due to what? Shorter prompts. And also, you want lower latency requests. But it takes a village to get this data set up and ready. So you need to worry about where do you get the data from, the data structuring. Is this a tape or someone actually? MashaAllah, MashaAllah. May Allah subhanahu wa ta'ala preserve him. MashaAllah. So data structuring, right? You need to structure the data. Usually it's JSON, and that's what we're going to do today. So you'll see the data in a JSON format. Data annotation, meaning some of the data needs to be annotated in that JSON. What does this do, right? You need to augment data as well, and now it's ready for training. I'll give you some practical examples. So you don't need 100 billion model for every task you have. For, let's say, real-world applications, anything between 1 and 13 billion parameter should be very practical for you. Because it's small, it'll usually give you a good zoom in, a good output for a certain task. You must check the licensing, be careful. I did this in Saudi. I used Llama, and a company in Saudi told me, sorry, we cannot do that. The license on the Llama asked them to have, there was like a condition where they need to, what was the reason? They need to be in courts in the United States or something. So they said, no, we cannot do that. Like if there's a dispute or something, the behavior changed. Similarly, in America, all companies, they tell you, please don't give me any applications that have any Chinese model in it. Because if this model started behaving in a certain way, who are you going to fight? Right? So you need to be super careful. So when you fine tune and you say, hey, I have a model, it's fine tuned model. Okay, what was the base model? All of these questions are going to come and legals are going to go after you. So you need to be super careful. Next, this is what I usually start, the 8 billion or the 2 billion. But today we're going to go actually way, way, way less because we don't have much GPUs. Okay, so an 8 billion parameter model will need about 16 gigabytes of what? Of memory to load up. We'll talk about precision and quantization, but you need also to think about this. A model, the base model usually is full precision. It's 16 floating points, meaning in each, remember that we said 8 billion parameters means the numbers that we were talking about. Remember the decimal numbers? So the more precision you have in these decimal numbers, the better the answers is. But then you can actually shorten them. You can go from 32 floating point to what? 16 floating point. And you could go to 8. So this process called quantization, there's a whole slide for it. So
the elements in the vector itself.
yes. These are the smallest unit of a model, right? So there's also something called batch size. Consider also using the model parallelism. This is what I was, the model parallelism and data parallelism techniques, and also documentation. Document as you go, because guess what? If you don't know what step and what model you used, what step and what algorithm you used while you were fine-tuning or preparing the data, it's gonna get messy. This is more of a technical way of doing it, but basically you have the model, you have the pre-trained weight, and you're using certain methods to have the outputs. What happens is, this is a method called QLoRa. So you have the original, now she's getting excited because she. So
statistics in this.
So this is, for example, one example called QLoRa. We'll get back to it, but there's so many other models out there. For QLoRa, let's just take it from a business side of view. What happens? You load the model, whether it's quantized or not quantized. Remember, quantized is like a smaller version of it. By smaller, I mean like less precision. You load the configuration. You load and configure the tokenizer, just like what we did previously. You load the LoRa configuration, right? Depends on like what configuration you use. And then you load the PEFT model. What does PEFT mean? Parameter efficient fine tuning. And then you load the encoder, and then you run the trainer. You will do all these steps, so don't worry. This is all theory as of now. Somebody asked me about distillation last week. Who was the one who asked me about distillation? Okay, so what is distillation? So you have quantization, which is in the next slide, and you have distillation. Let's talk about distillation. Remember we said the model has so much knowledge about the world. Chemistry, geography, multiple things. With distillation, what you do is you have a teacher model, which is the base model, which is the the model that you want to distill, and you have the student model. The student model will focus its attention to what? Focus its attention to one domain within that model. You're not quantizing it. You're not making it smaller in terms of precision, but you're taking one whole area that you want the model to focus on, and you want the student model to what? To focus on. So that distilled model, it's a whole science by itself. I remember when I was when I was interviewing for Cruise, this was like 3 years ago. All they wanted me to do is to go take a big model and distill it, because they have a lot of smaller use cases where they cannot serve big models. This is like on edge, meaning in the cars. They cannot go and serve a huge model because it will need a lot of computation. They need a student model, which is a smaller, focused, laser focused model of that big one. Okay, quantization. Just like we compress images, right? In multiple ways, there's multiple ways to also quantize a model. You can have make it smaller. You can make it less pixels, right? And there's multiple ways of doing it. But the idea is you have a 32-bit floating point, and you take it smaller all the way to 8. So please go ahead and click on this link. I'll share it in the slides. In the notes. It'll give you a nice review of what we need to do. So I'm going to put it after here. After exercise 1, there's a link. Please go ahead and click on it. It talks about quantization, the types of quantization. And by the way, when you are on Hugging Face, you will see what type of quantization, for example, here. You will see all of these names, by the way, and we'll study them. What does AWQ mean? 70B we know, but sometimes it will tell you the type of quantization that is out there, and the method that used to quantize it. So go to the link, please. Where's the link? Did everybody click on the link?
Show us the link again, please.
Oh, the link is here. After exercise 1?
The redhat.com one.
Yeah, the Red Hat one. The reason we need this is just scan it. Just go quickly over it with the person next to you and try to discuss. It tells you how the naming conventions for these models on Hugging Face goes. How is the version presented? How is the quantization also mentioned? So sometimes you'll see FP16. You will see W4A16, so that the method that was used, and so on. Please use this as a reference. Now, this is a very good reference to show you what is distillation, how is it connected to quantization, and the training, the embedding, and the tokenizer as well. Clear? So there are multiple, so just wanted to give you that. So please focus on the slides again. So there are multiple quantization level. There's a 4-bit quantization with simple uniform quantization method. There's a 5-bit quantization, and there's an 8-bit quantization, and that's the most famous one that usually people use because it's closer to the full precision. Multiple methods, and I give you a link for each method. You can go and read about it. Again, it's a whole science, but you will need it. When you have a project and you're working on a model, and then you'll have the SREs telling you, hey, this model is too big, we don't have the resources for it, you need to find a way to quantize it. There's multiple methods to quantize it, and you need to choose the right level of quantization.
So what do we use if we quantize to smaller bit stuff, like we get 32 bits?
Yes.
What are we losing?
What are you using?
What are you losing?
Again, look here. So, of course, you're losing less precision. You're losing the precision. When the model is, let's say, 32-bit, The answers you get are more, let's say, if it's a creative writing, then you will feel the difference. But if it's, let's say, a code generation, maybe not much as the creative writing. So what you're losing fidelity. You're using very particular, deep answers.
And the meanings
Depends. Depends.
the no
So
answer
if you
is-
distill and quantize, like you have to play with these factors. Depends on what is important for you. But these are multiple ways of doing it. So when you see the names, you will see GGUF, you will see AWQ, as you can see here. And these are the types of quantization that was used there. So don't just go and download anything.
What does AWQ stand for?
It's a good question. Let me click on this. Activation aware weight quantization.
Can we assume GGUF is the most capable?
I've seen GGUF is as the most used quantization. I'm not the one in the team that does quantization, but which means that I don't have much experience in quantization. But I've done a lot of distilling. Let's go to Hugging Face, please. And follow instructions on exercise 2. But before that, just go to Hugging Face. And click on models. So as you can see, with Hugging Face, you have a lot of data sets that will help you fine-tune. Actually, I'm one of the contributors for the Arabic data set, a lot of Arabic data sets. There's a bunch of data sets that we've contributed, alhamdulillah.
Like
But
what? Give us examples.
so one of them was the hadith embedder, the hadith embedding. Also ash'ar. We have a data set called ash'ar, meaning we went, because we know the technology and we know the language, so we took, let me give you a simpler use case. If you want to do tashkil, dexterization, what's the English word? Huh? Okay, it's very hard for me to pronounce, but basically to put the fatha, kasra, dhamma on words. So we supplied, for example, enough text to train these models. Enough representative text to train these models. So let's go to models. You would see about, 2 million models out there. Let's filter with DeepSeek. Go here, filter by model, and type DeepSeek. DeepSeek R1.
What's your model's name? What's the model you worked on?
Not model, it's a data set.
Data set.
I'll give it to you. Are we done? DeepSeek R1? Yes. So again, just to tell you what I did. DeepSeek, and then go to R1 and click on it. Now, this is called the model card. Guess what? You need to read it before you do anything. It's very important to know what the model is about, how it was trained. You'll see all of these technical terms that we were going. But I want you to go all the way down, and you will see something called DeepSeek R1 distilled models. You see the distilled models? Meaning someone kind enough found a way to distill the model and still keeps, let's say, 60 to 70% of its what? Of its original tasks. But is it going to work for my task? That's up to the experimentation. So go ahead.
They don't tell you what they distilled it to.
In this case, it's the general knowledge of the model was distilled to a smaller, as you can see here, it's 1.5 billion parameter. So in terms of size, it's small, but still keeps, of course, it's not going to be as knowledgeable as the, let's say, 70 billion parameter, but it's smart enough. You can think of it as a middle schooler or elementary, Okay.
Are they standardizing the names like they standardize
Exactly. That's the link I gave you guys to read. So you will know, for example, what does 16F means. You will know, whether the model was distilled or not, and then the method of distillation. But usually it's
Is
written.
there French influence in this because they're affecting the manufacturing industry in Detroit?
What's that?
Is there French influence in this distillation? Because
French?
they are changing the manufacturing landscape in Detroit.
I did not get that.
So we used to use inches when you had like tools. When you go to a wood shop and you had tools, everything was inches, and that's fraction-based system.
No, no, no.
So then we went to SI units, and we're millimeter, centimeter. It's not inches anymore; it's centimeter.
Hmm.
So that's base 10, and it's also changing now in the cloud.
I think this is different.
Okay.
This is not what you're explaining, basically. Okay, so and now I want you to download something called LLM Studio or LM Studio. You will see the steps here under exercise 2. Go ahead and download it from here. Oh, I don't have the link.
Is it LLM Studio or LM Studio?
No, it's LM Studio.
LM Studio, yeah.
So let me just put it in I forgot to put the link, sorry. So the link is there now. You could see it. Go ahead and download it. Has anybody used LM Studio before? You did? Okay. So he's lucky to have you next to him. So once you download it, you'll be able to see something like this.
So they don't have to. DeepSeek doesn't have to get approval from Meta to like distill their models or anything. When they make those distilled versions of Meta
Yes.
and like
No, because these are open source. Yeah. Once you put it there, halas. It's just like a GitHub repo, right? You can do whatever you want with it.
Can you distill at home, or do you need big machines?
You need big machines, but yeah, you need a GPU at least to distill.
But then you said that the llama people wouldn't let you. They would have to show up in U.S. court if there was ever a problem.
No. They just give it to you. You go and do whatever you want. But there's something wrong with the behavior. Who do you talk to? They usually protect themselves. But the Saudi government didn't like the terms they put in the license. So what I'm saying is, read the license before you use the model. Usually what I do, I take it, I throw it to our legal. They do the reading by themselves because they know what's good for us, what's not good for us. You downloaded, guys, the LM Studio?
20 minutes remaining.
Huh?
20 minutes remaining.
20 minutes?
It's slow here if you download it now.
15 minutes.
Question.
Yes.
We're in Saudi. Why can I voice call you on Snapchat, but I can't voice call you on WhatsApp? What's the WhatsApp disadvantage?
They just blocked it. They know that it's used by a lot of people, and they blocked. I think it's a monopoly by the wireless companies there.
Is there a download button missing here?
No. This is LM Studio. Did you download LM Studio or no?
Oh.
So
I don't
the
download
plan,
it.
the plan is. Let me show you. If you go back to the plan is we will download LM Studio, which is basically the place that we will use from now on to house all these distilled models, open source models, your own fine-tuned models, and so on. So it's a nice interface. It has a GUI and it has the CLI. Plus, you can manage everything, the chat and everything from that place.
I use it for the knowledge base, so I can build my own knowledge base inside it. It's actually amazing.
It's incredible, right?
Oh, that one.
Once you download it, if it's not there, so as it downloads, let me walk you through it. So this is what you're gonna do. So you come here, you come to search, you select a model. Of course, LM Studio is very aware of Hugging Face. So I want you to go and please pay attention. Hello, guys. So no problem. I want you to go here. So it says download. So we're gonna use the smaller one since the internet is very, very small, very bad. So I'm gonna go and say copy link, right? So I'm gonna copy link address to this one. I'm gonna go to the LLM Studio, paste it inside, and it's showing me. So it's doing a lot of some search and showing me two versions of it. There's this one, and I can see, the model card, and there's also this one. So if I click on this one, it shows me multiple types. So this one is about 1.26 gigabyte. The other one is about 752 megabyte. So I'm going to choose this one. And of course, you can click on it. You'll see like multiple versions of it. You can go and know what each one is. But I've already done this, so I'm just going to walk you through it. So now that I have the model, as you can see here, you can have multiple models. And again, I'm able to run it on my computer. Always go and check. See how much CPU you have. Don't just blindly go and have good memory. I have 16 gigabyte of memory on my laptop, so I'm good to play with these models.
How much does it need? Minimum.
I would say minimum is 8. Not to crush everything else on your laptop. So again, you can have like the models that you have. I have 2 models here. The one I just downloaded, and the other one is the 7 billion parameter Quinn. And I can go now and chat with it. You see, just like ChatGPT.
Can you also connect to the cloud versions or hosted?
Yeah. You can have VLLM and can you connect here to the no. This one is just for the local ones, right? The ones that you can host yourself. But if it's on a server, then you can imagine like what you can do.
16 gigabytes is good for any other LLM you use? Any other model you use is 16 gigabytes?
Yes, it will be not only the smaller ones, the distilled smaller ones. Okay, let me go and ask our flagship question, right? What is bigger, 3.9 or 3.1? Are you guys able to see what I wrote here? Okay, again, this is DeepSeek. Is it a regular model or a thinking model? It's a thinking model. And it's very small. And it's on my laptop. I'm not paying a lot of money. I just want to see what I can do with this that is on my laptop. 3 point what?
11.
11?
Yeah, because.
Let's see how smart it is, right? So from a mathematical point of view, which is bigger? 0.9. Let's see if the model is gonna do it. So as you can see here, it's thinking, which means it's generating a lot of. See, before it's answered me that 3.9 is bigger than 3.11, it did a lot of thinking, and we will go over the thinking, right? This is on my laptop. This is a very small model. It's a distilled model, and I'm able to get this intelligence on my laptop. Not only that, you can go to developer. You see developer here? It's ready. It's ready in forms of what? APIs. If I'm developing an app, I can just hit these APIs and start working with it. I can also, everything we've learned can be here. I can say how much it can think. It should not be thinking more than this because it's going to kill my, resources and all of that. I can customize the model. I can play with the temperature. As we mentioned, so much we can do. So how do I do this? You can go to terminal.
And do they default to using the GPU on your laptop? Or the MPU, I should say.
Say that?
Like these MacBooks have MPUs.
GPUs, only GPUs. Sorry, CPUs.
They don't have MPUs?
You mean GPUs, you mean? What do you mean by MPUs?
Neural processing unit.
They do.
So this defaults to using the MPUs.
That I'm not sure of.
Yeah.
But I assume it should.
Yeah.
So if you type LMS, you will see the same thing that you saw in GUI. You can use it as a developer, and you do everything you want, just like what I mentioned. You have the APIs here, and you start integrating your software with it. Cool or not? Did it download or not yet? Yes? Not yet? MashaAllah. Is it? Yes.
I think is NPUs like, you know, Apple always advertises like built for artificial intelligence. Is that just marketing speak for just GPUs?
No, it should be it should be doing that. Yes.
They have like a dedicated
But not sure if the software is actually taking advantage of this, because with GPUs you have CUDA, and all the software like VLLM and all of that leverages CUDA on that. But then when you have like TPUs or like you need to know what Apple or Google, are doing with their custom chips to start interfacing with it from a software perspective. Clear?
Question.
Yes.
For deploying like for enterprise processors, how would you do it with LM Studio?
So ML Studio to me is more of experimental. If I want to deploy it, I will use VLLM, which is an enterprise way of serving a model. LM Studio is for me, it's just a one-stop shop for everything model. So I try it. So this distilled model, for example, if I'm trying to build a mathematical tutoring app, I think this distilled model is more than enough for me. It's giving me the right answer. Usually I have my test suite. I have like 40, 50 questions, right? They're usually put aside. All I do is I throw them to the model, and then I have a script that will take the answers from the LLM and score. And I do it with, for example, 20, 30 models, and it'll tell me, oh, these models scored better. Now I know I don't have to go distilled or do anything. If it's not, then I have to go and either distill it myself or fine-tune it myself or do, the steps that I need to do by myself.
So the use case for this is to put it on edge computing?
Edge computing. So this one, for example, it fits on so you have a software or you have an app, and then you would say, hey, this app comes with a 500 million parameter app that is about maybe 200 or 300 megabytes that is next to the app. And then that communication between the model and the app happens when the app is loaded, as an example.
And with this, we can connect the APIs, like for real pre, we can like call it in this, just buy the API credits.
Yeah.
Do everything here.
Exactly.
Paying monthly subscription. Or
No, the architecture is like, you think about it like, how do you want to commercialize it? How you want to, I just wanted to show you like what's possible.
for personal use, we can connect APIs.
Oh, yeah.
And instead of like having subscription monthly, $20, $200, whatever it is, we can just call with the API whenever we need it.
Yeah.
Tokens are pretty cheap. If you're going to be connected to the internet and you don't need it to be local, then
Usually why do we do this? For enterprises. They don't want to send their data outside. That's pure, because if they're okay with this, or I'm doing it for a generic app that, let's say, that plans my trip, who cares, right? Who really cares?
One question: can you fine tune the LLM model here in order to use it inside the LM Studio?
Yes.
Oh, okay.
Not in the LLM Studio, but I'll show you. You need a GPU, but I'll show you. This is the next exercise.
Oh, okay.
So I'm gonna let the LLM Studio, but promise me, everybody, raise your hand. Raise your hand. I promise. I will download the model and test it. Khalas, I took your promise. طيب, let's go to the next exercise. Before I go to the next exercise, let's go back to the slides. Actually, let's fine tune a model. Let's go back to these exercise 3. Go ahead and download this data. So click on the link. You will have this file. So you'll see 3 files here. You will see fine tuning. Don't click on it. You will see model file, and you'll see JSON extraction dataset 500. Go ahead and download the JSON file. And talk to the person next to you what's inside it. Mm-hmm. The answer I want from you, how many examples are there? What's the nature of the fine-tuning data? This is the data you will be fine-tuning a model with. We will download a small model from Microsoft called Phi.
We're buying laptops.
And I wanted to do a specific task for me. So I just wanted to show you what it takes to train a model, how the data looks like, so that when you fine-tune it, you understand what's going on.
The Google Pixel made by Dell.
PlayStation by Apple.
I'm on LM Studio and I put the link in. Are these like I see that there's different names.
Yeah, it's fine. So just go with the one that is as small as it. Yeah, like this one 1.9. This one is 1.26. Okay.
So these just
No,
users
did you-
hosting these like models?
No. These are the ones that uploaded it to.
Oh, originally like the Hugging Face model. Okay, so it's not like some random guy just
No,
put in the
but yours is 1 point something. Mine was 700
yeah, I put
megabyte.
I put the exact link that
But
from
yeah,
the
but which one did you? Where did you go? Here.
I grabbed that
Yeah,
one.
the Queen distilled. Yeah, that's the right one. So yeah, it looks like it's gonna take forever to download. But go ahead and download this one. So you go and you download, and it's gonna take forever. So maybe at
Do the
home.
next step, yeah.
Yeah, just go and do the next step. Like I said,
Question.
yes.
I want to do we have questions at the end? Ask you
Yes.
Okay.
Yeah, we'll have enough time, inshallah, for the questions. Everybody, do you have your JSON file? Did you go over it?
Yep, 500 something.
About 500 examples. That's the least you can do when you fine tune. You need like about 500 examples, good, high quality examples. You see, somebody actually sat down and prepared these ones.
MacBook is made by Amazon.
Huh?
Xbox Series is by Apple.
Could be. All right. Once you download it, once you have it downloaded, go ahead and open this file. And this file is called Fine Tuning an LLM with Your Private Data. Click on it, and you will see this. So what I want you to do is go here. Look at my screen, please, because you will be asking me afterward. Click on this. Click on this. And then upload the JSON file that you downloaded. It should appear here. What I'm doing here, I'm just uploading the data that I'll be using for fine-tuning.
So I have to download the JSON file.
Download it, explore it, and then upload it to the notebook. Go ahead and run it, and you should see the first line of the file that you were working with. I just printed file 1, which is the first thing. Okay, so to fine-tune, there's so many other libraries, but my favorite library, and I use it all the time because I know the CEO. His name is his library's name is Unsloth. It's a well-known library. Unsloth AI. Pretty much a lot of like most of the companies that do fine tuning, they use Unsloth. They have also managed services, so they can help you. But we were using their open source, basically their open source library. So go ahead and download, or install Unsloth. It's gonna take about 1 minute probably.
So who's the CEO?
The CEO of Unsloth. He has a Chinese name. It's very hard for me. Let me find him. We met 3 times. The first time it was in a meetup.
You were going to say a Muslim.
The second time He came to our office. Mr. Han, Daniel. Oh, okay. Yeah. He did not have Daniel before.
Okay, I was gonna say that's not super Chinese.
Exactly.
Ooh, Australia or California? It's the middle. Poland.
Did we download it?
What do I need to click?
Yeah, just keep executing these. So the first one here, as you can see here, I want you to go to runtime and then click on change runtime type. So make sure you're choosing Python, but you can use any other language, of course, to do the same thing. And then use T4 GPU. This is the only one that Google gives for free. If you have subscription, then you can go with A100 or L4 as well. And it'll be faster to fine tune. You could use also bigger models as well.
Also, this GPU is at Google's data center. This GPU is at Google's data center.
Yes. We're doing this at Google because remember, we don't have it on our laptop. But you fine tune it, and then you what? You download it, and then you use it in LLM Studio. Right? So here, I'm just checking that you have, we're checking that you have everything ready. So I'm checking two things. That CUDA is enabled, which is basically if you're using Colab, it's usually configured for you. The second one is we're using a GPU from Google called Tesla T4. Do you see this, everybody?
Is it surprising that was the default option selected?
Yes. It's not surprising. But you can always go here and click. You will see like how much RAM is used, how much GPU is used, how much disk is used. You can also go and change, as we mentioned.
Give you that much for free?
Yes. Google. It's Google. We can ask, tell us like why Faris, they're so generous with the GPUs and everything. Survival mode? Okay. They have enough money instead of spending it on marketing and just give it to people, let them experiment. Because if you do it now, believe me, he asked a good question. He said, why Google? Why you're always, because that's what I usually use. That's what's available for me for free. I don't have to go and pay money somewhere else.
Could you do it locally on, like, say, a 16 gigabyte GPU on your laptop or a desktop?
Like fine tuning?
Yeah.
Yes. So I did fine tune on our rack in San Jose.
Okay. And how much VRAM did that have?
I used actually 4 H100.
Okay.
4 H100, but this was a big model, and it took some time. It was a 30 billion coin model, and I was fine tuning it for Arabic.
For what?
For Arabic.
Arabic.
So I wanted the model to, it's a RAG system, so I wanted it when it generates, it gives me like better Arabic outputs. We good? All right. So once this is done, go ahead and see. You will see that we're using Unsloth library. We're going to load Phi 3 mini 4K instruct BNB 4-bit. It's a very small model. Right? So don't worry much about these, but these are some of the parameters. Maximum sequence length. In this small model, the whole context window is 2000, not more than that. And the type is none, so you can it means like go ahead and auto-detect the type of the data that is there. And we're going to load the model. So go ahead and click on it. We're going to load the model. As you can see, I'm just using some parameters from the tokenizer and the model, but you can, of course, go ahead and read the documentation and play with it. Again, it's art. Just like any other machine learning model. You need to know what you're tuning and what you're playing. But these are toy examples, as we say. So model name, of course, takes the model name, the maximum length, which we said 2048. The data type, it's going to be auto-detected. And here said load in 4-bit. Remember the quantization that we said. And we said it's true. So it's going to take about some good time.
So what is it doing now? It's loading.
Yes, it's just loading the model. We will use LoRa here, which is one of the fine-tuning methods. Again, it's downloading the model.
Hey, it's so cute. I got a sloth.
You got a sloth? Okay. Because it's called unsloth. You see it? So the safe tensors is one of the libraries that is actually used. Again, unsloth is the library that is abstracting all this craze from you. It's making it easy for you to do that work. Just like pandas for or NumPy for data multiplication or data processing, or scikit-learn for machine learning, or PyTorch, or what's the other library? TensorFlow for machine learning and deep learning.
So Unsloth is on top of PyTorch? Like,
No, they use multiple. It's Python.
okay.
Not sure if they are. PyTorch, yes. And it's fully compatible with Hugging Face. Not only PyTorch, I've seen it. So it uses PyTorch, it uses Transformer. In this case, for example, it's using, safe tensors. So if you go to Hugging Face, right, it'll tell you, for example, you see if this one is a safe tensors, and it tells you the model parameter size and all of that stuff. So R1, there's adapters, fine-tuned, about 313 fine-tuned models, merged model, about 70 models that are quantized. But I'm happy, like, at least now you know what it means, where to choose. Again, we're trying to navigate this LLM landscape. Okay, so I'm done. I'm going to go ahead and load my data set. Again, I chose the right model, which is a very small model. I gave it the right parameters, supposedly. I loaded in 4-bit, which is a small quantized model. And here, all I'm doing in this line is I'm just trying to tell it, hey, it's in JSON. I want you to dump this JSON as what? As text. And when you fine-tune it, just treat it as text. It's just formatting. And now we're using we're using LoRa, a LoRa adapter. So what it does, LoRa does not go and fine-tune the whole model. Because if you fine-tune the whole model, what happens? It's very slow. It's going to do so much changes. So it creates a layer at the end of the model, the last layer. It adds one more last layer called adapter. You still can use the same model with multiple adapters. So remember the SQL I showed you for my company? When I ask a question, it'll intelligently choose the best adapter. What does the adapter do? Just like the adapter, right? When it answers, it gets multiplied by the last layer of the adapter, and it gives me the answers based on this. So I didn't actually change the actual model. It's actually the the model with the adapter combined.
So the weights of the original model are frozen, and you're only changing the weights of the adapter layer.
Yes, yes. Does that make sense?
That's smart. Okay.
It is smart. Yeah, that's why I showed you in the slides there are multiple ways of fine-tuning. There's LoRa, there's QLoRa, and each one has its own advantages. Again, we're not we're not getting into fine-tuning, but I'm just trying to tell you what's possible. So that when you go and read something, you have a good understanding of what do you need to do.
Do these adapters stack on top of each other, or it's mutually exclusive?
In here, we're just training one adapter. Yes, and sometimes you can go and find adapters out there, but you need to know what data was it trained on, all that stuff. Again, Hugging Face would be like if you're in the open source models, Hugging Face would be your your everyday, the place you live in. So let's review some of the models. Target modules, all of these are parameters. I hope we have time because at the end, I want to show you like what's inside a model, the layers, the down projection, up projection. This is like us zooming into training and fine tuning, but these are parameters, right? I'm using LoRa, which is one way to fine tune. In this case, LoRa alpha, one of the parameters for ranking. LoRa dropout. In this example, I said 0 because it's the most optimized. Bias, it's none. These are some of the recommendations of Unsloth. So go ahead and run this. And it should not take much time. So we just define the parameters, and now we have the model, we have the data, and we have the adapter. So now we're putting everything together. So we're using the trainer here. I'm just telling it what's the tokenizer, the data set, the sequence, and the size, all of that stuff. Here, the optimizer, it's called Adam. Have you guys trained any neural network before? So Adam optimize, basically you don't want to start from scratch. Adam optimizer is going to tell it, hey, start from these weights. And usually when we start from these weights, we get better results than starting from 0, 0, 0, 0, right? Think about it as a random initializer. A lot of other stuff. Yes?
The weights are the 8-bit and the 4-bit?
Yeah, the weights are the smaller units inside the model. Remember the model we said?
We distilled it to the student from the teacher and got all that.
Yes. So let's train.
Like when you say 1.5 billion parameters, those are 1.5 billion weights, right? Is that the same?
Yes. Yes. So it's going to take some time. You see? You guys are running everything? Because the goal is to have the model, download the model from the notebook. I gave you a way to download it from the notebook, and then plug it into what? To LLM Studio, and then start asking questions. At least you can say in your life one time, I actually trained, or sorry, not trained, that's a big word. I actually fine-tuned the model. Yes, the data is not mine, but at least.
So we're not going to be using this model, are we?
Huh?
Are we going to be using this model?
Are we going to be using this?
LM Studio?
Yeah. I want you to download it and then use it. Okay, there was a sister who wanted to ask questions. Where did she go? Huh? She's going to come back? Okay, so as it trains, let's take more questions. We're at the end of the class, so we still have like 10, 15 minutes. Please.
When do you have your model class here?
Model class.
Agents.
I did have one session, one workshop for agents. Who attended, guys? How was it? Was it good? We actually used Google, again, because it was free. We built multiple agents, and I can give you the link and everything else. I'll put it actually in the file, and the slides, and also the exercise. So it's self done. But I'm actually planning to have a whole agent class, inshallah. So Affan and the rest of the team, inshallah, will tell me when. Yeah, I'm traveling. Yeah, inshallah, I'm traveling this month, like for about a week and a half, inshallah, to California. Actually, I'm traveling after tomorrow, inshallah. But then I'll be back, inshallah, in December, and we can, December, January, inshallah. We'll find some. Again, this is taking a longer time, but what I want you to know is you will save it, it'll bring it, you will save it, you'll test it, and then it'll be from the GGUF, the one that you mentioned. All right, Assalamu alaikum. Go take it, put it in LLM, and start asking questions from the training set. See, the behavior actually changed. You can also go and download the exact model that you had here and see how it looks before. So if you go to LLM Studio, remember you'll have a library, right? You'll have a library of models. So I want you to load the original model and load the fine-tuned model and try to ask different questions and see if really changed, and then try to do something for your own. If you don't do it, you'll never do it. This is the best time to do it. If you don't do it, you will never do it. Best time meaning like this week. Because after this week, khalas. This will be history. Someone in the team will be doing this instead of you. Any other questions?
So Colab won't be enough to distill or try to distill. I can follow some of the tutorials somewhere. Distill from teacher to student model.
No.
Colab is not.
No, it is. It is actually enough. It's more than enough. If you go Google Colab distill model, you'll see a lot of examples. It's a whole nother class by it's like it needs like hours just to go and explain like every single. But as you can see, guys, like so many topics, right? I gave you breadth. I didn't go in depth. Like maybe in some areas, but no one knows everything. It's becoming tiring, right? For me, I'm a PhD. I graduated with a PhD. I don't read papers anymore. Back in the days, 2016, 17, I used to read the whole paper. Not anymore. I don't have time. I can't read all the papers. I just go and read abstracts, conclusion, and that's it. I just get enough. And then if the
Summarize it with.
I do. I use Notebook LM, the best, right? In 20 minutes, and even with like hard graphs and hard, it just gives me the very good, and I can question it, and put answers. These are some of the books that I highly recommend you guys read. Usually start with this one. Hands-on large language model. No, not this one. This one. Designing machine learning systems. I'll put this inshallah in the notes. Designing machine learning systems. O'Reilly, yes. Chip. She used to teach at Stanford. That's where I met her. Amazing book. The second one is by Jay Al-Ammar, Jihad Al-Ammar, remember his name. Hands-on large language models. This will teach you all about transformers, like deep in. If you work with data, this is a classical book. You should not, skip. Like if you work with large-scale data, this is like the most important book, basically. Designing large language models application. It goes over everything LLMs and how to build applications on the top of them. This guy is actually here in Toronto. I never met him, but I know friends who worked with him. And this is like if you want to get into agents and building like actual, becoming basically an AI engineer. That's one of the best books. Again, Chip. She's the one that wrote this book. So the book that I want to give away is this. So the first book. Okay? Now, I have a question. I'll ask a question, and if you answer, you get the book. Let me unplug and
Have an audio Google Studio thing running live to answer quickly.
something like this. No.
What should I ask?
In simple terms, what is the chinchilla scaling law?
Smaller model, more data
Smaller model, more data.
for a longer period of time.
Smaller models, if they are trained with the right data, they give similar results as or better results as the models with higher data.
Models are typically undertrained, so you should, for a given size model, run it longer with more data.
Mm-hmm. Yeah, I would say yes. Go ahead.
You have to do. This is the time it takes after it's trained to process the data, and compared, yeah, processing the data after it's actually trained or after.
Yeah, I think he gave us like the comprehensive one. Everybody just elaborated basically, and he was the first one who raised his hand. As he said, so the scaling law talks about three things: compute, data, and model. There was a time where there was a belief that the bigger the model, the more intelligent it become. But then the chinchilla paper came out and said, no, it's not about how big the model is. It's how big the model in respect to the data. Because they found out that there was a model like GPT-2. It was trained on a huge parameter size, but then it was actually under trained, meaning it was not supplied with the right data. They actually brought more data, and they show that you need to have balance between these three. Yalla, big hand. Again, these are available online. You can just go and get them. I'm an old school guy. Alhamdulillah, I read all of them, and I go and review them from time to time. So I highly recommend get your actual copy. Any other questions?
Looks like it's done. But are we going to have like a follow-up for agents?
Inshallah. So that's what we talked about. Yes.
Yeah.
He just donates it out of the goodness of his heart. We don't pay him or anything right now. Just like a little thing.
Well, yeah.